Okay, so we're going to be doing Leetcode number 167 to sum 2. The input array is already sorted. So this is an algorithm that you should do after doing Leetcode 1 to sum. And if you remember in Leetcode 1 to sum, it's easy. We couldn't use the two pointers method because the array we were given wasn't sorted. So since the array we're given now is sorted, we can simply use two pointers. So one at the front and one at the end. And we increment the one at the front if the sum that we get is less than the target, or we decrement the pointer at the end if the sum we get is less than the target. So let's read the question just to make sure. So you're given a one indexed array of integers, numbers that is already sorted in non-decreasing order. So this is non-decreasing order. Basically, they mean ascending. It's just the way they described it. So find two numbers such that they add up to a specific target number within this array. So you let within this array. So you let these two numbers be numbers at index 1 and numbers at index 2, where these two numbers lie within where these two indices lie within the range of indices. That's what this means. So return the indices of the two numbers added by 1 as an integer array, index 1, index 2 of length 2. So basically they want us to return the indices, but 1 based indices, right? So the tests are generated such that there is exactly one solution. You may not use the same element twice. You may not use the same element twice means that, for example, if the target was 6 and there's 2 3s and there's 1 3 in the array, you do not simply use the index of 3 twice to return a target of 6. So your solution must use only constant extra space. So the only way to do this is actually using two pointers. So for this, all I'm going to do is I'm going to first, I think we can type out the code because this is very easy and the asymptotic complexity is very clear, and then I can redo it I can redraw it. So let's start. So this is two pointers, right? So our first pointer is at index 0. Our last pointer is going to be at length of numbers minus 1, and then while I is less than j, right? We're going to find the sum, right? So sum is equal to, okay, let's call it local sum, is equal to numbers at I plus numbers at j, right? So now we're going to check for three conditions. If local sum is equal to target, then we're going to return the indices of I and j, right? But plus 1, because we want them to be 1-based indices. So if it was at index 0 and index 4, right? If I was at 0 and j was at index 4, then this would have been it would come out as 1 and 5. So we return I plus 1, j plus 1, right? Elif local sum, which we calculated, is greater than the target, then we decrement the pointer at the end, which is our j pointer. Else, it means the local sum is less than our target. So we increment it to move forward. And then this is optional. Like if you want, you can add this minus 1. But since they said the tests are generated such that there is exactly one solution, you can do without this, right? So let's run this and see. Voila, it works. So let's test it out without this. We're going to just comment out the return statement. Since they said that it's guaranteed to have a solution all the time, that means we never reach this return statement, so you don't need it, right? So it even runs a bit faster. So now let's draw the algorithm and see how it works, right? So to have a very good input, we're going to use this input. So this is our input array: 2, 3, 4, 5. Let's make this 9. And then our target is going to be, let's make this 8, right? So our target is going to be 7, right? So we're going to use 2 pointers. So we have a pointer initialized at I and at j, right? And what are our indices? Our indices are 0, 1, 2, 3, 4, right? So I, j, we're going to keep track of our I and j values. And then we're going to keep track of whether I is less than j. And then we're going to keep track of the sum of the values at indices I and j, right? And then we'll just have here target for sum, the target of 7 for some comparison, right? So our I and j start at 0 and our last index, which is 4, right? So is 0 less than 4? Yes, it is, right? So we calculate the sum. Our value at index 0 is 2 plus our value at index 4 is 9, which gives us 11. Is 11 equal to the target of 7? No, it is greater. So what does that mean? We reduce the j pointer, right? So we move this guy here, right? So we come down here. Our index I is at, our pointer I is at index our pointer I is at index 0. Our pointer j is at index 3. Is 0 less than 3? Yes, it is. The value at index I is 2 plus the value at index 3 is 8. 10. Is 10 equal to 7? No, it is greater than, so we decrement our j pointer. The decrementing of the j pointer means we are now pointing here. So we're now pointing at, our I is at 0, our j is at 2, index 2. Is 0 less than 2? Yes, it is. Our value at index I is 2 plus our value at index j is 4, which gives us 6. Is 6 equal to 7? No, it is less than. So that means we increment our I pointer, right? So now we are at our index I is at index 1. Our pointer I is at index 1. Our pointer j is at index 2. So is 1 less than 2? Yes, it is. Our value at index I is 3 plus our value at index j is 4. This gives us 7. Is 7 equal to 7? Yes. We have found the two numbers that add up to 7. But we're not just returning their indices I and j. We are returning them plus 1 according to the instructions of the problem. So this will give us these indices plus 1, which will be 1 plus 1, 2 plus 1. This will be 2 and 3. And the runtime complexity of this is O of n, because in the worst case, you'll have to run up to close to, for example, if you have an input whereby you had to run up either all the way close to the last 2 or all the way close to the first two. I don't know if that makes sense. So that means that runtime complexity is O of n, but the space complexity is O of 1, since we haven't used any extra space. So yes, that is our solution to sum 2. And for this, I actually did the code first because this is an easy question, and although it's considered medium, if you I think actually you should be able to do this first before doing sum, because this one is easier. All right, so that's it, and thank you.